Hi everyone! Today we are diving into something really exciting. We are going to build an AI powered product description generator using Amazon SageMaker and Google's Flan-T5 model. So, if you ever wondered how to deploy AI models in a production environment, or if you're looking to automate product content creation for your e commerce platform, this tutorial is perfect for you. And before we dive into the code, let me give you a proper introduction to Amazon SageMaker. SageMaker is a fully managed machine learning platform for AWS. It's a game changer for ML deployment. Think of it as your complete AI ML workshop in the cloud. Instead of spending hours or even days setting up servers, managing infrastructures, and dealing with scaling issues, SageMaker handles all of that heavy lifting for you. This means we can focus on what matters: building and deploying our AI solution. Now let's talk about what you'll need to follow along this tutorial. First, you'll need an AWS account. If you don't have one yet, don't worry, you can sign up for free and get some credits to start with. You'll also need a Hugging Face account because that's where we'll be getting our model from. Apart from that, you'll need some basic Python knowledge to go with the flow. Let's talk about what we are building. Our goal is to create a system that automatically generates professional product descriptions. Okay, now let's start with the practical implementation. First, I'm going to show you how to set up your development environment in SageMaker Studio. As you can see, I'm in the AWS console and I'm going to search for SageMaker. And once you're inside SageMaker and create your domain and the user profile, get into SageMaker Studio. This will be our IDE where we'll write and test all our code. Let me give you a tour of the interface. On the left side, you will see the file browser and the resource management panel. This is where we'll manage our notebooks and endpoints. Understanding this layout is crucial because we'll be switching between these panels frequently as we develop and debug our application. Before we write any code, let's discuss some fundamental SageMaker concepts that you'll need to understand. First, we have endpoints. These are HTTPS API endpoints that will host our model. Think of them as the access point where our application will communicate with our AI model. Then we have instance types. These are different hardware configurations. We'll be using GPU instances because our model requires parallel processing capabilities. We also have IAM roles, which handle permissions. This is crucial because SageMaker needs to interact with other AWS services securely. In our case, we have given access to S3, SageMaker, and CloudWatch events. And finally, we have CloudWatch, which is where we'll monitor our endpoints' performance and catch any issues that come up. Now let's dive into the code. We'll start by importing unnecessary dependencies and the libraries. Let me explain each of these imports in detail. Boto 3 is AWS Python SDK. It's like a communication bridge between AWS services and Python. We use JSON for handling our data formatting when we send requests to our endpoint. SageMaker gives us access to SageMaker's functionality, particularly the Hugging Face model, which we'll use to deploy our Flan-T5 model. Let me now explain the configuration. This is where we'll make some important decisions about our deployment. Let's break down why we've chosen these specific configurations. First, we've used Google's Flan-T5 Small as our model. I specifically chose this model for a few reasons. It's publicly available, no special access is required. It's relatively small at just 80 million parameters. It's been fine-tuned for instruction following tasks, and it performs well for text generation while being cost-effective. For our instance type, we're using MLG5X large. This gives us one NVIDIA A10G GPU with 24 GB of memory. When you're deploying AI models, you need to match your hardware to your model's requirements. The Flan-T5 small model easily fits within this memory budget, leaving room for multiple requests. Now let's set up our environment variables. This is crucial for proper model deployment. These environment variables are like configuration settings for our deployment. The SM number of GPUs tells SageMaker to use one GPU. The maximum input length and the total tokens control our text processing limits. This is important because it affects both performance and cost. Larger values mean more processing time and higher resource utilization. Now comes the exciting part, actually deploying a model. Let's first create a Hugging Face model instance. The version numbers here are very critical. It's like building with Lego pieces. Everything needs to fit together perfectly. The transformer version needs to be compatible with our model, and the PyTorch version needs to work with both transformers and a GPU instance. Okay, now let me show you how we deploy this model. This is where our configuration comes together. We're using initial instance count of 1 because we are starting with a single endpoint for development. In a production environment, you might want multiple instances for load balancing, but for our learning purposes and to manage costs, one instance is just perfect. Okay, so when you run this code, SageMaker starts creating your endpoint. You'll see it right here in the endpoints panel. The process usually takes about 15 to 20 minutes, and during this time, SageMaker is provisioning the GPU instance, setting up the container environment, downloading the model, and starting the inference server. Since we already ran this command, let's now build our product description generation function. This is where the prompt engineering is really crucial. Notice how we structure our prompt. We are essentially giving the model a role, telling it that it's a professional e-commerce product description writer. And notice how we structure our prompt with clear instructions. This significantly impacts the quality of our output. Now let's look at how we actually make the API call. The maximum number of new tokens, which is set to 600, is our response length. Temperature set to 0.7 gives us a good balance between creativity and consistency. Toppy, which is set to 0.9, helps maintain quality while allowing for some variation. The doSample parameter, which is set to true, enables more natural sounding text. Perfect. Now that we have defined the parameters, let's invoke our endpoint and test our endpoint with a real product. I'll use a hiking backpack as our example. Let me run this and show you what happens. Look at the description that our model has generated. Notice how it incorporates all the key features and speaks directly to our target audience of hikers. Let's try another example, but this time with a different product type to show how versatile our system is. How about a smart coffee maker? Okay, so while we are generating these descriptions, I want to show you something important in CloudWatch. Look at these log metrics. These logs show if your model loaded successfully. If you see any 404 errors or memory issues, they'll appear right here. Before you close the console, remember to always delete the resources and the endpoints. As you can see, a total cost for this project stayed well within our budget, making it practical for both learning and development purposes. Let's wrap up this tutorial with some important takeaways and next steps. Today, we have built a complete AI-powered product description generator using Amazon SageMaker and Flan-T5. Let's recap what we've accomplished. We've set up a SageMaker development environment, deployed a production-ready ML endpoint, created a robust prompt engineering system, implemented proper error handling and cleanup. And at the end, we managed our cost to stay well within our budget. For those of you looking to extend this project, here are some exciting possibilities. You can add support for multiple languages. You can implement batch processing for multiple products. You can fine-tune the model for specific industries. And you can integrate this with e-commerce platforms. I've included all the code we used today in the description below, along with links to AWS SageMaker Documentation, Flan-T5 Model details, cost management guides, and the example implementations we covered. If you run into any issues or have any questions, drop them in the comments below. Don't forget to check out the AWS documentation for more advanced features and optimizations. Thank you for following along and happy coding.